Okay, good morning. So last class we were in the discussion with okay. Good morning to all. We have been discussing the last topic, processing offloading. And in the previous class, we have seen that the three main categories which we have to discuss further. So we have seen this is the entire model where you can see the sensing, local processing, edge processing, as well as fog and cloud computing. So the main category which we have to discuss today, what are those? So the main three things what you have to discuss today is offload location. Then you will be discussing on offload decision making and offloading consideration. So in the previous classes we have discussed exact module 3 and we have also discussed on these three. Today we are going to discuss in detail these three things in detail. What do you mean by offload location, offload decision making and offloading considerations? What is offload location? Yeah, here processing can be offloaded in the IoT architecture. That process is called as offload location. What are the different categories of that we will be discussing? Then offload decision making. In this case, where the offload the processing and by when and how much you have to do the offloading process. We will be discussing there, and offload consideration. So these are the three categories which we are going to discuss in detail. So let us see the first one. What is the first one? Offload location. So what do you mean by offload location? So here you can see that the offload location decides the cost of that susceptibility as well as applicability of the entire IoT architecture or applications, and it is categorized as edge. So we have here categories as edge, fog, then we have remote server and cloud. So we will be seeing first one is edge. What do you mean by edge? Edge means what? See, in the figure you have already seen. See, you can see local processing, edge processing, fog processing and cloud processing. You have already seen these things. So let us see what is edge. So edge means what? So what is basically offload location? It deals with applicability, cost and susceptibility of the IoT applications, and we can distinguish the offload location into four categories, that is edge, fog and what are the other two? Other two is remote server and cloud. So first one we will see what is edge. What is edge? So in edge processing you can say that the offload processing of which the data processing is facilitated to at the location or near to the source of the data generation. So it will be processed at the location or very much close to the means very much close to the data location. Means like you can say that you are having a temperature sensor or any surveillance you are doing, the processing will be carried out either at that point or very much close to that point. Okay. So here the edge is done to achieve what are the parameters like manipulation, bandwidth reduction, then aggregation. All this process can be achieved by using the edge process, where when you are doing the process of offloading the data. So these are some of the things what will comes under edge. What is the next one? Fog. So fog we have already discussed before also in the previous modules as well. What is there in fog computing? See, it is decentralized computing infrastructure. Fog computing, you can say that it is a decentralized computing infrastructure, and which utilizes to conserve network bandwidth. See, you know that these are some of the parameters which when we are focusing like latency, bandwidth, cost of the entire network. All these are some of the parameters when we have to consider when we are setting up any network. So we can say that in fog computing, it is a decentralized computing infrastructure, as well as you can say it conserves the network bandwidth, reduces latency, and restricts the amount of data unnecessary flowing through the internet. That is very important. See, if any unnecessary data is there, it is going to restrict those data. It is going to utilize the bandwidth in a precise manner, as well as it is going to reduce the latencies. So that is what you can say at the point of fog computing it is going to do. And the data, computing, storage, applications are shifted in place in the process, which reduces the latency as well as the network bandwidth usage. See, we have to make sure that the bandwidth as well as the latency is kept at the minimum. So it means you have to reduce the latency as well as you have to make sure that the bandwidth usage is appropriate. You are not supposed to use more number of data to the network, and you should not overload the entire network, which is required for you. That information only you need to share. Okay, these are the things. So we have seen now two offloading locations. First one is edge and another one is fog. So what is edge? What I understood from edge? Yeah, the data processing is facilitated to the location or near to the location. And what you can see in the edge computing, you can also say that it achieves aggregation, manipulation of and bandwidth reduction process can be achieved in the edge computing. So what is the next one is fog computing. In fog computing, what is there? Yeah, the main things is decentralized computing infrastructure. Fog computing is called as a decentralized computing infrastructure, and what it is there, you can say that conserves the network bandwidth, reduces latency, as well as restrict the amount of data unnecessary flowing through the internet. So these are the things what the fog computing is going to take care of it. Okay, and you can also say that the data, computing, storage, applications are shifted in place, and which results in the reduced latency. Means when you are having data, then storage and applications are in place. You can say that you can reduce the latency as well as you can have a better bandwidth utilization. Means you can utilize the bandwidth properly. So these are the two things what we can say. Another two are what? What are the other two? One is cloud, another is yeah. So we will be seeing that. So this is clear for you. Offload location, fog and edge is clear. So let us go for the next one. You can take it on later. So next one is remote server and cloud. So what happens in remote server? Remote server, you might have also come across remote servers and all those things. what happens in remote server? What happens in remote server? Remote server, what you can see. So remote server with good processing power can be used as one of the applications for offloading processing from resource consideration. So you can use this remote servers as a with good processing power can be used as for data offloading, and you can say that what are the features, what it is a rapid susceptibility, and maybe an issue of with respect to remote servers. So what you can see, the cost and it is costlier as well as hard to maintain in comparison to solutions with respect to clouds and all those things. So some of the features it is there which is to be taken into consideration. Cloud computing. Cloud computing, I think most of you you would have come across. So what are the features of that? Cloud computing is configurable computer system. So you can see in the figure we have seen. Have you drawn that figure? So in cloud computing, what you can see, the data storage, then cloud-based infrastructure, and all those things are there, isn't it? So it is cloud computing is configurable computing system, and which can configure resources, platforms, high-level services through shared pools. All these things are possible in cloud computing. Then what is this? What is possible then? Process resources can be rapidly with minimum effort into the internet. So you are going to connect all the devices which is going to be connected to the cloud, and the entire process of computing, entire things can be carried out in the cloud process. Okay. So cloud enables massive scalability of solution. This is very important. So whatever information is there, you are going to process it to the cloud and cloud platform, and you are going to have the massive scalability of solutions, and which enables resources enhancement, allocation, user or solution to on-demand requirements, as well as you can say that through the pains and acquires configurable, and which also reduces the, or it is whether it is cost efficient or more cost will be there when you are going to cloud computing. So it is configures costly hardware. So more cost related hardware, because will be having more processing of information to be carried out there. Okay. So these are the four basic offloading. What is the first one? H. So is that clear for you? Is that clear? So these are some of the features which we have studied. So we have studied edge, then for remote server and cloud computing. So next is what? What is the next thing? What is the next thing we have studied? First one is data offloading we have seen. Second one is what? Offloading location. Offloading location. So we'll go with the next one, offloading location. Sorry, offloading decision making. So offloading location is clear for you. We have seen X, then we have seen fog, remote server and cloud. Then we will be going with offloading, offload decision making. I send you the slides. I send you the slides. You can download it. So offload decision making. So decision making means what? The choice where to offload and how much to offload. You have to be in a position to make a decision that how much to offload, where to offload. Means where this data has to go. How much information has to go there. For example, you may have lot of information with you, but you don't share it with anybody, right? So you think that okay, if I say this much of information, it is enough. So you say that where to offload. You may not offload the information to everyone. You will say, okay, this is my close friend, so I will say so much of information. I will say more information. It will be too much of offloading of data, so it is not required for me. So I will just say little bit. How much I have to share, that much I will say. So we have to understand where to offload, how much the data has to be offloaded, and major factors in the deployment of offsite processing topologies based on these things. We'll be saying that the decision making is a very important category of offloading, where generally addressed considering that data generation like that generation rate. We have to consider the generation rate, then network bandwidth, and critically the applications processing resources availability. All these features has to be considered. So the first, there are some of the approaches. So we'll be seeing three main approach. The first one is naive approach. The first one is naive approach. The second one is bargaining based approach, and the third one is learning based approach. So we'll be seeing the first one, naive approach. What is that naive approach means? What? See, for example, now you have some information you are sharing to your friend. You have three different approaches to think. One approach is like the first one is naive approach, then bargaining approach, and the third one is learning approach. Let me start with the learning approach. First, you have told some information he or she has shared with everyone. You share with that, and you have a learning process that you will not do it further again. Okay, that is learning approach. Bargaining approach means what? He is trying to snatch out the information from you as much as possible, but you have something, you bargain in yourself, means you don't send the information as and when it is required. You protect your information and do it. Naive approach means what? See, naive approach is a hard approach without too much of decision making. Without thinking too much, you share everything. You say that, okay, let me try. I will share all the information, and further that information will be given to you. So, naive approach, let us say that it is a hard approach without too much of decision making process. You are going to have the sharing of information. It can be considered as the rule based approach. This is very important. It is called as the rule based approach. Like when you have certain information, you have certain rules also, whether this information is to be shared or not to be shared, or these are the classifications which you have. So it is a rule based approach. This is very important. It is a rule based approach in which the data from IoT devices are offloaded to the nearest location. So whatever information is there in the node, it is being transmitted to the nearest location as per the rules. Okay. Then it is easy to implement because you are not doing much here. Whatever information is there based on the rules, you are sharing it to the neighboring node. Okay. So here it is never recommended. Is that recommended? No, it is never recommended, especially for dense deployment as well as deployment where data generation rate is high. Because there is whatever information is there based on the rules, whatever it is assigned to that, it is going to share it to the neighboring rule. So, if for example, if you need some privacy or some security, all those process, sometimes it is going to, if that rule is not there, it is going to share your information, isn't it? So that is there. Not only that, it is very easy to implement. No hard core structure is required or no hard infrastructure facilities are required. Whatever rules are there, based on that, the information keeps on moving further. But what is that? It is never recommended. In some cases where, especially for dense deployment as well as for deployment where data generation rate is high. In these categories, we don't go with this approach. Okay. Then statistical measures are considered for generating the rules. So how to define the rules, what are the rules to be trained, all those things are done using the statistical measures are considered for generating the rules for decision offload. So this is offload decision making. The first method is naive approach. What you understood in this? It has a set of rules and it is going to follow those rules when it is going to have a data transfer, and that is not preferred for some of the cases where like especially for dense deployment. Dense deployment means what? If you take a classroom, you are to deploy 60 nodes. Okay, it is very dense deployment. You are not leaving much of the space. Whatever information is coming, you need to collect it from that. So you are going to have a dense deployment there. Okay, those cases we don't recommend these things, as well as for data generation rate is high, where the very high data generation rate is there. There also you are not going to prefer this method. What is the next one? Bargaining based approach. From the word itself, you know it is bargaining based approach means what? So this approach is a big processing initiative and decision making means basically on network traffic congestion as well as enhances the service quality of service. Basically, you can say that it parameters such as bandwidth, latency, and all those things are considered in this case. Okay. So what you can see here is, by trying to maximize the multiple parameters, the most optimum solution it can be attained, or not all the parameters can be treated for equal importance. For example, if you are working on the latency, you may have to sometimes sacrifice the bandwidth. If you are working on the bandwidth, you may have to sacrifice the other parameters. So it may change depending on the requirement of the user. See, this is the thing. Bargaining based solution is trying to maximize the quality of service. The quality of service, it will help in maximizing the quality of service by trying to reach to the qualities of certain parameters and reduce while others are enhanced. It will help to maximize the quality of service. What next is that? So you have heard about game theory. Game theory. You might have heard about game theory, which is one of the common example for this bargaining based approach. Okay. And you can say that this approach does not need to depend upon. This is very important point. it does not depend upon the historical data for decision making. Means what has happened before, it doesn't matter. So whatever decision it makes instantaneously. It doesn't look into the historical data like you have shared the data to your friend has shared to everyone. Doesn't matter for the bargaining approach. Okay, you again share that and make sure that the things should happen. So that is what here. Then the last approach is learning based approach. Learning based approach means what? You heard about machine learning? Yeah, that approach would be learning based approach. Okay. What happens to you? To take your case study. You are around 60 nodes here. You are sharing your information. Learning based approach means what? Unknowingly you share some information and it reaches to everyone. So you learn yourself that that information should not be sent further to anybody. You train yourself. You train yourself, right? What you do, as I told, you train yourself. Once you train, then same information or same pattern of information comes to you. Will you repeat it again? No, because you are learning process say that you have done this process before and you got sufficient feedback. Does not do it. You are not supposed to do it further again. So what you will do? Your learning process will make sure that what is required, that information only will be shared for the nodes. So learning based approach rely on past behavior and the flow of and the data flow in the IoT architecture. Okay. So optimization of quality of service parameter is the learning takes place. See how the learning takes place. Once once you do some activity, you learn from that. Again, you do the next activity. You keep on learning. You keep enhancing your database, and you keep make sure that you learn the process again and again. But you don't repeat if you feel like this process is carried out. Either you do it in that way or you do it in some other way based on your learning. So for this, what is that? Memory requirement and processing requirements are very high for this learning based approach. The best example for learning based approach is machine learning. So machine learning is the best approach for the learning based approach. Okay. So these are the three categories which we have studied in offloading, decision. So is that clear for you? The three approaches. What are the three approaches? First one is take approach. Second one is marketing, and third one is learning. Want to note down anything? Or we go for the last concept. What is that? Offloading consideration. So again, these offloading considerations we have already discussed before. So what are those parameters? See here, offloading considerations are while deciding upon offloading type to choose. For example, you can say the nature of IoT applications and the hardware being used in the interaction. So offload considerations, you basically go with bandwidth, latency, all these parameters. What are the parameters we have studied before? Bandwidth, latency, and we have also studied the resources, criticality, and data volume. So these are the parameters which depends upon the offloading considerations. So let us take the first parameter, bandwidth. What do you understand by bandwidth? You should tell me what is bandwidth. Capacity of it. Maximum bandwidth is the maximum amount of data that can be simultaneously transmitted from one node to another, from one point to another, simultaneously. For example, see you travel in a road, no? There will be maximum amount of vehicles that can travel at one point. So that is the capacity of that node, isn't it? Similarly, bandwidth means what? The maximum amount of data that can be simultaneously transmitted over the network between 2 points is called as bandwidth. Okay. So the bandwidth of a wired and wireless network is also considered for data carrying capacity in the data network link and all those things. We have to consider that how much data can be transmitted from one node to another at a single point of time. So that is called as bandwidth. Is that clear for you? Bandwidth? Bandwidth is simultaneous transmission of data from one node to another. How much amount of data can be transmitted from one node to another? We have already discussed about latency. Yeah, latency, you know that time delay incurred between the start and completion of operation in the entire network. So in the entire network, what is the time delay it has taken from the start and completion of the data? This delay is taken for the data to transmit from the start to the completion. That is called as latency. We were coming across this term many times, isn't it? So latency arises due to the physical limitations in the infrastructure. Because of the infrastructure limitations, it can lead to latency, as well as you can say that operations can be data transfer over the network or processing of data through the processor. So because of the hardware infrastructure or because of many other parameters also, the time taken for the node for the data to transmit from one node to another. So that is called as latency. You can say that time delay which takes, for example, you take some time to travel from here to there. So that delay may not be same for all the people same. 60 people, 60 times difference. So based on your hardware infrastructure, you can travel fast and slow. So based on many parameters, it depends how you can. So what is bandwidth? The amount of data. So bandwidth is the maximum amount of data that can be simultaneously transmitted from one node to another, one point to another. Latency is the time delay incurred between the transmission of information. Okay, in the entire network. So is that clear for you? So what is the next one? What is criticality? Criticality also we have discussed in the previous class. Yeah, criticality means what? The importance of the task being pursued by the IoT application. Which is important? Whether this set of information is important or the other set of information is important. So that is called as criticality. More critical a task is, the lesser latency is expected from the IoT. Means what? For example, you have seen healthcare or military applications or some other applications where flight related applications and all, where every bit of information is very critical. Anything like you delay for half an hour, 1 hour and all, the latency is more than what it will happen. It will impact the output. Okay. But when you are going with agriculture applications, criticality is not too much. You can have a data transmission with half an hour delay or 15 minutes delay and all. It's not going to impact too much. So the response time in turn to milliseconds, some cases it is very important. Even a millisecond is important in the transmission of data. Then what is that resources? What is resources? Yeah, resources is significant capability of offloading location. How much the capacity of the resources is there to entire offload the entire information, and processing power. What are the algorithms used there? What is the capacity of the hardware? how much resources is available there in that node, all those things. What is the power, what is the energy capacity, what is the processing capacity, all comes in the resources. So allocate useful allocation of processing resources, reserve for real-time multimedia application, high energy initiatives, huge volume of data storage capacity, then address nominal resources without wasting much of energy. All these things comes under resources. What is the last one? Last one is data volume. That is very much clear for you. You know that how much volume of information you put into the internet, you take out from the internet, all those things you know that, right? What is data volume? Amount of data generated by the source simultaneously handled by the offloading location is referred to as data volume. Means this is the bit of information you are holding it and you are passing on to the output. Means you are offloading the entire volume of information. So, for large dense IoT applications, offload location should be robust enough and address the processing issues also. So, it should be capable to address whatever data volume it is there. See, for example, you know that you are using Facebook, WhatsApp, and all so many applications. You a lot of information you keep on uploading and you keep on downloading the data. So, your infrastructure facility, your all those things has to be quite supporting. Okay, it should be quite up to date to support all this information flow and information uploading process. So we have seen in this what are the things we have seen. All these informations we have discussed before as well. So we have seen offload considerations as bandwidth, latency, criticality, resources as well as data. So this is all about this module. If you have any doubts, we will discuss it again. I think I have touched upon all the points, whatever it is relevant for you. Okay. So any doubts or anything is there, you can feel free to discuss. So we'll close this here. So this is all about the module 3. Next class we will be starting with module 4.